Good morning, children. Today we will discuss about the redox reaction and electrode process. Okay. Redox reaction and electrode process. Now, when I say electrode process, means it is a process which might be occurring in a electrolytic cell or electrochemical cell, that will be called as the electrode process. So, in an electrochemical cell, you will find that there is redox reaction occurring. You all must have learnt about this redox reaction occurring in a vessel where you are taking CuSO4 copper sulphate, and to this copper sulphate solution you are placing a zinc strip. Okay, a zinc strip is placed here. So what do you observe? In the beginning there you won't find any change, but after a period of time you will find that there is a layer of golden substance. It is deposited on this strip. Okay, this is the golden Cu deposition. That golden color is because of the Cu deposition. Actually what is happening here? Here also you will find that there is a redox reaction occurring. ये जो CuSO4 है, this is in the form of Cu plus 2 ion and SO4 2 minus ions. Okay, whenever you say CuSO4 aqueous medium में है or CuSO4 solution, what does it mean? It means that actually there is Cu plus 2 ions and SO4 2 minus ions in this solution, and this zinc strip is kept here. So which are the two reactions, that is oxidation and reduction, occurring here? You will find that zinc being more reactive than copper. Okay, zinc will be going into the Zn plus 2 state with the release of 2 electron. So this equation you can call it as oxidation reaction. This is the oxidation reaction. Okay. Similarly, CuSO4, which is existing as Cu plus 2 and SO4 2 minus, those Cu plus 2 ions will take the 2 electron and get to Cu. Now again this is a redox reaction, reduction reaction. It is reduction reaction. Now both are occurring together and they are in direct contact with each other. The Zn strip is in contact with CuSO4. So this kind of redox reaction is called as direct redox reaction. Okay. So this will be called as the direct redox reaction. Okay, and this is a kind of electrochemical cell which is formed. Now what is an electrochemical cell? You cannot call it as an electrochemical cell because we cannot draw the energy from here. You just simply see that the deposition of the copper is taking place on the zinc strip, and this oxidation and reduction reactions are occurring. But ये जो reaction है इससे हमें कोई फायदा नहीं होता है. But if you make this reaction, you modify this reaction and create an electrochemical cell from which you can draw current, then that will be helpful to us. So we will now discuss about construction of an electrochemical cell. Okay, construction of an electrochemical cell. First and foremost, you should understand what is an electrochemical cell. Electrochemical cell is a device or a setup by which you can convert the chemical energy into electrical energy. So what is occurring, what is the principle here? That chemical energy is converted to electrical energy. Is converted to electrical energy. This is what we call as electrochemical cell, a device where you convert chemical energy. How do we obtain the chemical energy? We obtain the chemical energy by the reactions which are taking place. So now this same reaction, if you do it in a different manner or you make a separate setup, say for example, you are taking the zinc strip, okay, this is the zinc strip, okay. This zinc strip you are taking in the salt of the same metal, that is zinc strip you have taken, Zn strip, okay, and it is placed in ZnSO4 solution, followed or not, okay. So this is how you keep your zinc. And copper, what do? You take another vessel, and in the another vessel you take copper sulphate solution, you will take, okay, CuSO4 solution, and in this copper sulphate solution you will place the copper strip. Both these strips are joined by a metallic wire which is connected to say an ammeter, okay. It will help us to measure the amount of current passing through it, or galvanometer which will indicate the presence of electric current. You do it this way, okay. So what is happening here in this process? You have made an electrochemical setup here, okay. You have placed the zinc strip in the zinc sulphate solution and copper strip in the copper sulphate solution. You have separated that. वहाँ पे जैसे किया था उनको separate vessels में ले लिया. This zinc strip will undergo, when it is in the solution, this zinc strip will undergo the oxidation reaction, giving what? Zn plus 2 ion plus 2 electron, okay. Now this solution will be present with, already there is Zn plus 2 ions, more and more Zn plus 2 ions will be formed here, okay. And electrons, these electrons, they travel from the external circuit to the copper, okay. So this is your copper sulphate solution, okay, and in the copper sulphate solution the copper plus 2, Cu plus 2 ions and SO4 2 minus ions will be existing. Similarly here Zn plus 2 and and SO4 2 minus ions will be present. So these electrons, they travel here, and these electrons, they will be taken up by the Cu plus 2 ions which are present here, and there will be deposition of copper, okay, or copper gets reduced here. What is happening here? Here Cu plus 2 will take the 2 electron and you can get Cu. So this is the oxidation reaction, this is the reduction reaction occurring. But after some time, a period of time, what will you find? कि Zn plus 2 आयन का concentration यहाँ बहुत ज़्यादा हो गया, और यहाँ पे SO4 2 माइनस का आयन का concentration बहुत ज़्यादा हो जाता है. एंड क्यों ज़्यादा होता है? क्योंकि Cu plus 2 converts to Cu, तो प्लस 2 आयंस का अमाउंट कम होता रहता है, SO4 2 माइनस आयंस का अमाउंट बढ़ता रहता है यहाँ पे, ओके. सिमिलरली यहाँ क्या हो रहा है? Zn plus 2 आयंस आर बिकमिंग मोर एंड मोर, SO4 उतना ही रहता है. सो देयर इज अ पोटेंशियल क्रिएटेड, यहाँ पे पॉजिटिव चार्ज ज़्यादा है, यहाँ पे नेगेटिव चार्ज ज़्यादा है, ठीक है. ऐसा होगा तो सेल विल नॉट वर्क, ओके. सो व्हाट इज डन? यू आर प्लेसिंग अ सेटअप विच इज कॉल्ड एज salt bridge. What is this called as? This is called as the salt bridge, okay. And what is the function of the salt bridge? The function of the salt bridge, अब salt bridge मैं बोल रही हूँ तो what is this actually salt bridge? This salt bridge contains substances like KCl या फिर KNO3 और ammonium nitrate NH4NO3, those kind of substance which do not react with either of the ions, neither Zn nor Cu nor SO4, okay. So this kind of presence of these substances will allow the travel of the SO4 2 minus ions to Zn, making the electrochemical cell neutral. Otherwise, here positive charge develops, here negative charge develops, and to maintain neutrality of the electrochemical cell, this salt bridge is useful. Okay. So, that is the function of the salt bridge. Followed? So, SO4 2 minus ions, it will allow only the passage of the ions through it, and the substances in the salt bridge are taken in such a manner that there is no reaction occurring between the ions which are moving through it nor the Zn plus 2 ions. Okay. There is no reaction between the ions which are present in the half cells. Okay. This is plugged with say cotton wool. Okay. So, this is what we call as an electrochemical cell. Okay. अब जिस पार्ट में ऑक्सीडेशन होता है, the part of the cell where oxidation occurs, that is called as oxidation half cell. What is it called as? It is called as oxidation half cell. Half cell है, पूरा cell नहीं. Together they make a complete cell. Okay. This part where the reduction occurs will be called as the reduction half cell. Reduction half cell. Now, the whole chapter of electrochemistry in your 12th is based on this only. So, that time we will be learning in very detail about it. Now, you just understand what is a electrochemical cell, how redox reaction is occurring in the electrochemical cell. So, here oxidation half cell will have oxidation reaction occurring there, and reduction half cell you will have the reduction reaction occurring. Clear? Okay. Salt bridge allows the neutrality of the cell to maintains the, what is its function? It is to maintain the neutrality of the cell. Okay, neutrality of the cell. Now, why does the cell becomes polarized? Yeah, why, how the positive charge, negative charge develops? That is because as the Zn is going into the solution as Zn plus 2 ions, the amount or the concentration of Zn plus 2 ions at the oxidation half cell increases, while the amount of SO4 2 minus ions will go on increasing. That is, SO4 2 minus ions is not actually increasing, but there is a decrease of Cu plus 2 ions taking place. तो यहाँ पे नेगेटिव चार्जेस इंक्रीज हो जाता है बिकॉज ऑफ SO4 2 माइनस. यहाँ पे द Zn plus 2 द पॉजिटिव चार्जेस आर increasing, and if that is the situation, the cell will stop working, and therefore to maintain the neutrality we are placing this salt bridge which allows the passage of ions from one half cell to the other half cell, maintaining the neutrality. ठीक है. So, this is called as oxidation half cell, this is called as reduction half cell. Okay. Now, another thing to be noted, since you find that the number of electron, that is, this is the place where electrons are produced. Okay. Therefore, it will be called as the negative pole. What is it called as? It is called as the negative pole. इसको नहीं बोलेंगे, not the strip, but this half cell will be called as the negative pole. Okay, this whole half cell will be called as the negative pole, and here what is happening? Electrons are being consumed. Okay, so you can write here negative pole. Why do we call it as negative pole? Because electrons are produced here or formed here. Okay, electrons are formed here, और यहाँ पे CuSO4 will be, that is reduction half cell, it will be called as the positive pole. Positive pole. Why? Because electrons are consumed here. Okay, it is consumed here, electrons. Therefore, it is called as positive pole. और किस तरह से हम बोल सकते हैं ये particular cell को? You call this particular cell as anode. Okay, क्यों? क्योंकि anode ऐसा जगह है where oxidation occurs. Always in anode you will find oxidation occurs. ठीक है. जबकि इसको क्या बोलते हैं हम? कैथोड बोलते हैं where reduction occurs. Okay. reduction occurs. So that is how this construction is followed. This is the electrochemical cell where energy is obtained, electrical energy is obtained by the chemical energy. उस तरह का जो setup था, that was called as direct redox reaction. This will be an indirect redox reaction because here the redox reactions are occurring at two different places. They are not in contact with each other. There the oxidation and reduction together it is occurring in the single vessel. जबकि यहाँ पे it is occurring in a separate vessel. So this will be called as indirect redox reaction. Okay, indirect redox reaction. Okay. Now there is a particular way to represent the oxidation half cell and the reduction half cell, and there is a particular way to represent the whole cell, whole electrochemical cell. तो वो कैसा है? I will just rub out this, okay, so that you can I can write it there. I hope this is the very simple thing, you can understand it. Okay. So oxidation half cell, let me write that first. Okay, oxidation half cell. The representation of the oxidation half cell, इसको हम electrodes भी कहते हैं. Okay, this cell, this is the anode which is positive electrode and cathode. We will not call it as positive electrode. This is the electrode where you are having the oxidation being occurred and that is reduction being occurred. Okay, so oxidation half cell में you will find electrodes are usually the strips which you place in the electrolyte. So Zn is an electrode which where oxidation occurs. Copper is the electrode where reduction is occurring. So oxidation half cell we represent as, see, Zn strip or Zn solid is placed in ZnSO4, that is Zn plus 2 aqueous. Okay, this is how you represent oxidation half cell. Okay, reduction half cell, how do you represent reduction half cell? Reduction half cell, एनोड को इस तरह represent करेंगे, कैथोड को. reduction half cell, what is happening? Cu plus 2 is in contact with Cu solid. So this is reduction half cell, representation of reduction half cell. अभी इधर मैंने एक्वस लिखा है, अगर कॉन्सेंट्रेशंस दिया है CuSO4 का या कॉन्सेंट्रेशंस दिया है ZnSO4 का, then you should write that concentration. Okay, now cell representation, yeah, representation of an electrochemical cell, representation of an electrochemical cell. How do you represent it? See, you will always write the anode first, that is the negative pole or the where the oxidation is occurring, that you will always write to the left, and where the reduction is occurring, that you will write always towards the right. That is the conventional way of writing the cell. So Zn solid slash Zn plus 2 aqueous. ठीक है, अब ये दोनों सेल्स के बीच में देयर इज अ सॉल्ट ब्रिज, और वो सॉल्ट ब्रिज हम किस तरह रिप्रेजेंट करते हैं? डबल स्लैश. ओके, देन कम्स Cu plus 2 solution in contact with Cu which is solid. So this is how you represent a cell. Okay, so representation of cell, it can be asked. So this is just the basic thing what you have to learn about an electrochemical cell. Why are we learning it? Because in the electrochemical cell also there is redox reaction occurring, and this is how the redox reaction is occurring. Got it everyone? Okay. Okay, copy it down. Now, when we learn about the electrochemical process where you have this electrochemical cell, there are strips of, यहाँ पे हमने Zn का लिया था, Zn which is present in ZnSO4, okay, and we have Cu strip present in CuSO4, ठीक है. तो these are the two electrodes, the Zn and the Cu will be called as the electrodes. Zn is the negative pole and copper is the positive pole, okay. So this strip, it will be called as the electrode, okay. Now this electrode has the tendency to get oxidized and this electrode has the tendency to get reduced, ठीक है. The two vessels are connected with a salt bridge. I had told you that salt bridge में substances like KCl या NH4NO3 or KNO3, these kind of substances are used. Also somewhere you will find as agar, okay. This is also a material which you are using it as in the salt bridge, okay. The strips, they are connected externally with the ammeter and say a switch, okay. If the switch is closed, then no current will flow. Now, what is the path of the electron? Now, electrons will move from this strip, okay. If the switch is closed, then current will flow, that is electron will flow. Otherwise, if it is open, then there will be no flow of electrons, okay. So, this is the path of the electron. Then what is the path of electric current? Electric current will be in the opposite direction. You should understand that, okay. Now, since the zinc electrode has the tendency to, the flow of electric current is possible only because if there is a potential difference created, isn't it? So, this particular electrode will have an electrode potential and this particular electrode will have another electrode potential, okay. Now, what is electrode potential? Electrode potential, it is the tendency of an electrode to lose electron or to undergo oxidation or to undergo reduction, okay. Tendency of an electrode to undergo oxidation or reduction, ठीक है. तो इलेक्ट्रोड या तो इलेक्ट्रॉन लूज करेगा और ऑक्सीडेशन अकर होगा उसमें, या इलेक्ट्रॉन विल बी गेन्ड एंड रिडक्शन विल बी अकर. सो इलेक्ट्रोड पोटेंशियल, इट इज द टेंडेंसी ऑफ एन इलेक्ट्रोड टू अंडरगो ऑक्सीडेशन और रिडक्शन. इफ द इलेक्ट्रोड इज अंडरगोइंग ऑक्सीडेशन, तो उसका क्या हम मेजर करते हैं, दैट इज ऑक्सीडेशन पोटेंशियल ऑफ दैट इलेक्ट्रोड इज measured, okay. So, Zn का हम oxidation potential, because Zn has more tendency to get oxidized. So, therefore, Zn का हम oxidation potential measure करेंगे. और copper का हम क्या measure करते हैं, reduction potential, because copper has more tendency to get reduced. So, therefore, the reduction potential of the copper will be measured, okay. Now, there is an electrochemical series which is given to you in your book also, it is given, a table is given where you are arranging various elements based on their either oxidation potential, value of oxidation potential or value of reduction potential, ठीक है. What did I say? What is reduction potential? Reduction potential of an electrode is the tendency of an electron to gain electrons, of an electrode to gain electrons, And what is the oxidation potential of an electrode? It's the tendency of an electrode to lose electrons. Okay. Now in your book there is an electrochemical series given where you are arranging the metals either in the increasing order of their standard reduction potential. स्टैंडर्ड रिडक्शन पोटेंशियल हम लोग बोलते हैं, तो मतलब हम रिडक्शन पोटेंशियल किस कंडीशन में मेजर करते हैं? एट 1 एटमॉस्फेयर प्रेशर एंड आवर टेम्परेचर, स्टैंडर्ड टेम्परेचर. ओके, तो वो टेम्परेचर स्टैंडर्ड कंडीशंस में जो मेजर करते हैं उस इलेक्ट्रोड पोटेंशियल को स्टैंडर्ड इलेक्ट्रोड पोटेंशियल वी कॉल. ओके, स्टैंडर्ड रिडक्शन पोटेंशियल और स्टैंडर्ड ऑक्सीडेशन पोटेंशियल. नाउ हियर आई हैव put few elements which we usually come across in the increasing order of the standard reduction potential. Standard reduction potential. ठीक है, तो ये मैंने किस तरह अरेंज किया है? ये एलिमेंट्स हम लोग यूजुअली यूज करते हैं. सो दे आर ऑल अरेंज्ड इन सबका स्टैंडर्ड रिडक्शन पोटेंशियल के अकॉर्डिंगली अरेंज किया है. लिथियम का सबसे लोवेस्ट, इट विल हैव लोवेस्ट स्टैंडर्ड रिडक्शन पोटेंशियल SRP, एंड F विल हैव हाईएस्ट रिडक्शन potential. Okay, you will find that reduction potential of Li, क्योंकि Li तो एक मेटल है, उसका क्या टेंडेंसी होता है? To give electrons. It will not get reduced. It does not have reduction. Means what? You are taking or you are gaining electrons. So lithium has the lowest standard reduction potential and F has the highest reduction potential. Okay, so as you move from top to bottom, you will find that standard reduction potential, increases. Okay, and if you move from bottom to top, that means arrow upwards, then you will find here you are finding standard reduction potential increases as you move down. So the standard oxidation potential increases in this direction, that is upward direction. सबसे कम standard oxidation potential is F minus और सबसे ज़्यादा स्टैंडर्ड ऑक्सीडेशन पोटेंशियल इज फॉर लिथियम. सो लिथियम हैज हाईएस्ट स्टैंडर्ड ऑक्सीडेशन पोटेंशियल. ठीक है, और F minus has lowest standard oxidation potential. Followed? So these are few things which you should remember. Electrode potentials, I have not written the definition. Electrode potential I have written. Reduction potential of an electrode or oxidation potential of an electrode, वो क्या होता है? ऑक्सीडेशन पोटेंशियल हम कोई भी इलेक्ट्रोड का बोलते हैं तो वो क्या होता है? इट इज़ द मेजर ऑफ और द टेंडेंसी ऑफ दैट इलेक्ट्रोड टू लूज इलेक्ट्रॉन्स. ओके, ये सब कंपैरेटिव वैल्यूज़ होता है. Zn से ज़्यादा ऑक्सीडेशन किसका होता है? Cu का. सॉरी, Zn इज़ मोर, इट इज़ हैविंग मोर टेंडेंसी टू गेट ऑक्सीडाइज्ड दैन Cu. लेकिन अगर यही सेल, अब ये सेल हमने Zn और Cu यूज़ करके बनाया है. If you are making this cell with Cu and Ag, then Cu will undergo oxidation. Okay, Cu will undergo oxidation and Ag will undergo reduction. Oxidation potential of Cu will be more compared to Ag. यहाँ पे देखो, इसमें भी से भी तुम पता चल सकता है. Standard oxidation potential increases as you move from bottom to top. तो नेचुरली ये नीचे वाले का सबसे नीचे वाले का कम होता है ऑक्सीडेशन पोटेंशियल. Ag का ऑक्सीडाइज होने का टेंडेंसी कम है Cu से, isn't it? So Cu will get oxidized and Ag will get reduced that time. ठीक है. The Zn and Cu electrochemical cell is also called as, ये जो cell है, this is named, a special name is given to it. It is called as Daniell cell. Followed everyone? Okay, so these are few things which you should understand. Electrochemical cell, the electrons are passing through the external circuit, ions are passing through the salt bridge. Okay, ions, actually this salt bridge is also giving a contact between the two cells, otherwise how will the contact be? So solutions के साथ contact में ये salt bridge रखता है, okay, between the two vessels. So that is there. So these are the things you should understand here. Okay, I hope it is clear with you, these topics. Okay, so this completes this chapter. Next time we will take another chapter. Okay.